I'm the speaker because I have the best hair, but I'll start with that. We want to promote the use of biomarkers of aging in clinical trials. Being mindful, there are hundreds of clinical trials each year, and they do not assess biomarkers of aging. And so why do we want to do that? Goal one is we feel it's important to measure biomarkers in the study participants at baseline. Why? To assess whether the control group and the treatment group are comparable. Many drugs fail because there's a mismatch in biological age. So if you measure it, you can correct for it statistically. What is new in our approach? Well, we propose that people set aside one blood tube, and then we measure multiple omics readouts, proteomics and methylation, because these are fairly routine and highly informative. So our value proposition is that we protect against failed clinical trials due to a skew in biologic age. If you correct for it, maybe the treatment does work. And also, we will build a foundational genomic database. If every clinical trial measures the same biomarkers, then people can mine these. Why is that important? Because an interventional study allows you to get at causality. You can say this changes in response to that treatment. So you establish a virtuous cycle. You identify, on the one hand, perhaps treatments that rejuvenate us, but conversely, by having treatments that affect the biomarkers, you can decide which biomarkers are working well. So you find good treatments, good biomarkers, good treatments, good biomarkers. Then, as the next steps, we decided that we will develop and present some PowerPoint slides outlining guidelines for the measurements for future clinical trials. What should people measure? And so we said proteomics, methylation, but possibly other things. And then we want to contact various people and stakeholders. So for example, the mouse interventional testing program really should measure a lot of these biomarkers. We want to perhaps even reach out to the FDA. Apparently there are wonderful organizations like Foundation Medicine that already collect various clinical trial data. And I'll stop with that. Anyone else? We have 5 minutes.
My thought on this also was that the best biomarkers are the ones that deal with mechanisms of aging. So they allow us to measure aging, and they allow us to measure aging well because they're part of the signal that is the driver of the aging process. So that if it's just like Steve was saying, if the markers are based on biological reality, and then you understand the biological reality better as a result of measuring the markers, then the biological reality improvement in understanding lets you understand the markers, which markers to choose better too. Didn't say that very well, but anyway, I think you got it.
Yeah.
And I just want to point out that we started out wanting to get to surrogate endpoints for trials and have approval for that, and so that's still the goal. And some of the things that Steve talked about are sort of first steps or intermediate steps that are possibly achievable first. And then one of the things he mentioned, contacting the ITP, was maybe trying to get that surrogate endpoint aspect achieved for at least preclinical.
Yes.
And we seem to have an opportunity also in the UK to do something quite interesting with a group called Our Future Health. So they're recruiting 5 million volunteers. They're collecting blood samples, healthy volunteers, longitudinal sort of research project. And we talked also about sort of extending what we look at sort of into the exposome sort of territory, looking at other sort of lifestyle, sort of obesity, diet, nutrition, that sort of stuff, as part of our approach.
And to be clear about the dollar sign amounts, I think all the things we suggested are in the under 1K.
We want to have causal biomarkers because we want to know what we want to target with our interventions, and that they matter. Changing them matters, and we want to also be able to persuade regulators that we're having an effect and it's positive. And probably this will involve new technologies, like new measurement devices beyond what we have today.
Wonderful. We have 2 minutes for Q&A now. I already see some hands up. Constructive criticism, Q&A, whatever you want to make it.
In looking at past clinical trials, do you consider looking at the healthy control arm for clinical parameters? So to have a benchmark of aging, like ejection fraction, bone density, muscle gain or loss. So then you could also use that as to accelerate future trials as well, to have a benchmark of aging.
Can you add transcriptome?
We did talk about it, single cell transcriptome in blood, and there was a comment that it takes a long time to administer the protocol. See, we don't want to burden these companies. If it's something easy to do, they will do it, But, yeah. All right. Then, well, we'll add it to the PowerPoint slides for sure. Yeah, please.
If people are randomizing their treatments, why would you expect there to be a skew that would change your interpretation of the results?
Oh, that's easy. Because of small sample sizes, bad things happen. You sometimes end up with a control group that is really healthy and resilient, just by bad luck, But yes, if you have a large...
If you look at baseline tables of lots of published studies, you'll see skews on various comorbidities or on chronological age. And so just, the whole point is look at biological age as well.
Fantastic. Thank you, guys.